Hello, we are Security Ocean, Team 9. I'm Brady Lewis, and today I'll be presenting both the installation of OpenVAS and the network changes required to ensure the scanner function effectively within our virtual environment. Together, these two areas form the foundation for building a reliable vulnerability scanning setup. To begin, the main goal was to install and configure a fully functional OpenVAS instance on a Kali Linux virtual machine. This included setting up all major components, such as the Greenbone Vulnerability Manager, the scanner engine, the web interface, and the supporting database services. One major success was completing the installation without any blocking issues. Once installed, OpenVAS recognized its components and initialized them correctly. Another important highlight during installation involved updating system dependencies services like PostgreSQL, Redis, and various libraries required updated versions to stay compatible with the latest OpenVAS release. Updating these ahead of time prevented startup errors and ensured smoother communication between the scanner's engine and its backend services. As installation continued, I optimized the network configuration so the scanner could communicate with target systems. Using a combination of NAT and host-only networking allowed both internet connectivity for feed updates and direct communication with the lab machines. After configuring the network, I ran test scans to confirm that the scanner, database, feeds, and reporting tools all functioned properly. Now, with these installation milestones were positive, several challenges did emerge throughout the process. One recurring issue involved OpenVAS feeds freezing or failing to synchronize. Updated vulnerability information is essential for accurate scanning, so I had to manually restart the feed sync service multiple times. Another challenge was scans, especially against Metasploitable, freezing at 0%. At first, this seemed like an internal OpenVAS issue, but later I discovered the root cause was related to the network configuration problems rather than the scanner itself. There were also occasional service installation delays. PostgreSQL and the Greenbone Manager sometimes failed to start automatically and required manual restarts. These delays showed the installation but didn't prevent completion. These installation challenges set the stage for the next major part of the project, which was the network changes needed to stabilize the environment. Which brings us to the second portion of today's presentation, the changes made to the network. Network modifications were just as important as the installation itself. One major highlight was implementing dual network adapters, using NAT for downloading updates and host-only for direct communication with target systems. This solved many of the connectivity issues encountered earlier. Another important improvement involved assigning static IP addresses to both the scanner and target VMs. DHCP was causing IP changes that broke scan profiles, so switching to static addresses ensured consistent connectivity. Additionally, I verified all required ports and protocols between machines. OpenVAS relies on ICMP for host discoverability and specific TCP ports, including 9390 for Greenbone interface. Ensuring these ports were open helped prevent timeout issues. Finally, I created a dedicated internal subnet specifically for vulnerability scanning. This isolated testing traffic from the host's primary network and ensured more consistent, controlled scan results. Of course, these network modifications also had challenges as well. One of the biggest issues came from using the wrong adapter mode. When the VM was set to NAT only, OpenVAS could not communicate with Metasploitable and scan was froze at 0%. Switching to host only, or bridge modes, solved this issue. Another challenge involved mismatched subnets. At times, the scanner and target systems were placed on different IP ranges, causing communication failures. Reassigning IP addresses to the same subnet resolved this problem. There were also DHCP conflicts inside VirtualBox. DHCP occasionally assigned overlapping IPs, which caused intermittent connectivity loss. Switching to static addressing eliminated that issue entirely. Lastly, firewall interference, both from the host and the virtual machines, blocked ICMP and necessary TCP ports. Adjusting these rules allowed OpenVAS to communicate properly with its targets. Next up, we have Tiffany with the top 10 vulnerabilities shown through Metasploitable, Kali, pfSense, and Security Onion virtual machines.
Thank you, Brady. As Brady mentioned, we have the network, which includes the pfSense firewall, the Security Onion SIM, the Kali VM, and a Metasploit web server. The chart here lists the top 10 vulnerabilities across that network. From top to bottom, we have the vulnerabilities listed from high to medium, the vulnerabilities being common vulnerability scoring system. Across this network, we had 22 high vulnerabilities. We also had 42 medium vulnerabilities and 11 low vulnerabilities. The Metasploit web server itself had 22 high, 40 medium, and 6 low. We included the pfSense firewall and Security Onion because pfSense firewall is the first line of defense in depth, and Security Onion failed to configure correctly and did not install correctly, leaving us with an unknown number of vulnerabilities. That rounds out our top 10 list. Now I'm going to hand it off to Ben to start the discussion on the high CVSS scores.
Thank you, Tiffany. The first vulnerability that we have here is the remote execution service vulnerability, which allows users to execute remote commands through a local host using the system shell. This vulnerability should be remediated right away by disabling remote execution in the system services and using Secure Shell instead. Secure Shell provides a secure and encrypted tunnel for remote communication on unsecured networks. Second, remote login is a service that allows users to access systems remotely. This particular vulnerability allows a malicious actor to log in without needing any credentials. The service already transmitted credentials in plain text, making it vulnerable to password sniffing, a technique which allows attackers monitoring the network to intercept the packet and harvest the credentials in plain text. However, this vulnerability allows an attacker to masquerade as a trusted host stored in the remote host file, which remote login uses for authentication. Security practitioners are strongly advised to disable this service and use Secure Shell instead. Third, VSFTPD, or the Very Secure File Transfer Protocol daemon, is a protocol that enables file transfer between a client and server. This particular version of the service includes a known backdoor that can be exploited to remotely access the host without any access credentials. This vulnerability should be remediated as soon as possible by uninstalling it and using Secure File Transfer Protocol instead. Therefore, a malicious actor would not be able to intercept the communication and read the file's contents without authorization. Now I'll pass it back to Tiffany to talk about more of the vulnerabilities.
Number 4 is an operating system identified on the Metasploitable web server being end of life. End of life means that there is no patch support available. This means that any vulnerability that is current to today would be a 0 day for this specific operating system. Recommendation is to remediate. Install and replace the OS with a vendor-supported OS. Additionally, migrate only essential data to the new system that is crucial to business operations. Distributed Ruby is number 5. Distributed Ruby is a known remote code execution RCE, which allows users to run scripts and execute commands remotely. Recommendation is to remediate and mitigate. Install the latest distributed Ruby patches and disable port 8787 if possible. TWiki cross-site scripting is also another known RCE, which allows users to take over the website with an HTTP request. Recommendation is to remediate and mitigate. Install the latest version of TWiki and patches. Additionally, add input validation and sanitization for user input fields. Number 7 is HTTP misconfiguration for delete and put. This allows users remote access to upload malicious files or delete files from the web server. Recommendation is to remediate and mitigate. For all users, explicitly deny all HTTP methods on the web server except GET and PUT. With distributed Ruby, TWiki, and HTTP misconfigurations all associated to web applications, there is an additional recommendation that we make for these 3. Recommendation for a configuration change, add and configure a web application firewall. Now I'll hand it over to Jacob to continue talking about our vulnerabilities.
Thanks, Stephanie. The most serious issue we found is on the MSF host port 1524 is running on the interglock backdoor, which is a well-known sign of compromise. This suggests that the system has probably been tampered with or was set up on a purpose with a malicious backdoor. Since we cannot fully trust a system once a backdoor is in place, the only really safe fix is to completely wipe it out or rebuild it from scratch. Trying to clean or repair a compromised host usually leaves behind hidden malicious changes. For the pfSense, the main issue we found is that the web GUI isn't setting the HTTP only flag on its session cookies. Basically, that means client-side scripts could potentially access the cookie, which could lead to the session being hijacked. If there's a cross-site vulnerability, the fix is pretty simple. pfSense should be the only HTTP only attribute turned on for all session cookies. We also recommend doing an internal check to make sure this oversight does not cause any unexpected risk. With Security Onion, the problem is more about how it's set up. The system is missing key parts like SO InfluxDB. The SO status command shows that several systems either fail to deploy or turn on. Even after trying a clean installation, the platform still isn't working as it should be. That means Security Onion isn't a reliable capture. It doesn't analyze security events, which really weakens our monetary capabilities. Now I'll be passing Ben to finish off with the conclusion.
Thanks, Jacob. In conclusion, vulnerability scanners are crucial for any organization serious about its cybersecurity. For one, it allows for identification of previously unknown vulnerabilities. This is especially useful in networks with hundreds or even thousands of endpoints. Second, it allows for categorization, which allows you to score vulnerabilities based on their severity and potential to cause harm. This guides efforts and urges security teams to address the most secure vulnerabilities first. Third, it allows for a recommendation of solutions. These solutions help security teams with limited resources determine the ease and cost of mitigating the vulnerability. Having more data allows more informed and strategic decision making. Lastly, regular use of vulnerability scanners begins to establish a culture of proactive instead of reactive security. Organizations should focus on transitioning from responding to incidents to preventing them before they can happen to prevent the most harm. With this tool, organizations can secure their assets now and for the foreseeable future. Thank you.